Hi, this is Mr. Shumway. This video clip is a review of items that we will want to have fresh in our mind when we take a benchmark 1. We don't have a chance to retake this one, so let's review before. If f of x equals 7, so whatever value I put in for x, I get out a 7. What is the value of f of negative 7? Well, that would be 7. Doesn't matter what value x is, the function evaluates to 7. Joe needs to buy supplies for a birthday party. At the store, balloons cost 31 cents each, and party hats cost $1.39. If Joe wants to spend less than $20 on the party supplies, complete the inequality below to represent the number of balloons, B, and the number of party hats, H, that he can buy. So if we have $1.39 times the number of hats, and we have something times the number of balloons, well, that one would be 31 cents, so 0.31, 0.31. Okay, so if Jeff modeled the number of minutes that he read each day during the first week of the summer, the recursive function f of x can be used to determine the number of minutes that he had read after a certain number of days, where x represents the number of days. So the function on the first day gives us a value of 27. The function evaluated at any other day after that gives us, I have to look at the function the day before. That's what the x minus 1 means. So if I want to know on the second day, I have to look at the first day and add 10. So we're going to use this function to evaluate after 5 days. So on the second day, I go to the first day, that was 27, and I add 10. So that gives me 37. Whoops. So on the third day, I take my 37 and I add 10. That gives me 47. And so I just keep going to the day before and adding 10. Fourth day, it would be 57. Fifth day, it would be 67. So Peter gets paid a flat rate of $14 to mow his neighbor's lawn, plus an additional $6 per hour to rake the leaves. The money he earns is represented by the equation m equals 6h plus 14, where m represents the amount of money he earns in dollars, and h is the number of hours he rakes leaves. If he was paid $47, he must have raked leaves for how many hours? So we know that the money he earned was 47, and that was equal to 6 times the number of hours raked plus the 14 for mowing. So if we take away the $14 for mowing, that gives us $33 is equal to 6 hours, 6 times the number of hours. So to find out how many hours he worked, we just divide by the $6 per hour. So the number of hours equals 5.5. That makes sense, because 30 divided by 6 is 5, and 3 is half of 6. So he raked leaves for 5.5 hours, got paid $33 plus the 14 for mowing. That added up to 47. Plugging it back in and checking it. Haley has an account that earns simple interest. The value of her account can be represented by 3,200 plus 1 times 1 plus 0.04t, where t represents the number of years the account has been open. So this would be a simple interest. The numerical value of the initial dollar amount of the account. So the initial amount would be 3,200. Now it goes up by 4% every year, but it starts out at 3,200. Manufacturer wants to create a box that has a height of 4 inches, a length of x inches, and a width that is 4 inches less than 3 times the length. So 4 inches less than 3 times the length. Well, we said the length was x. So 4 less than 3 times that. So I 3 times it and then subtract 4. And so in our inequality, we have the volume is length times width times height. So we have 2 of those. Which one are we missing? We're missing the height. The height is 4. So that has to be greater than 500. Similar situation. The height is 6. We have that one multiplied into our volume. We have the length. Yep. And then we say that the width is 2 inches less than 5 times the length. Well, there's 5 times the length. So 2 inches less than that, we have to put a minus 2. And there's a minus already there, so we just put the 2. The function h of n describes the height in inches of a rubber ball on the nth bounce. So it starts out at 62. The first bounce is 62. The next one would be 2/7 of that. So you go to the one before it. So if I wanted to find the second one, I would go to the first one. So n minus 1 would be 1. And do 2/7 of that. Well, 2/7 of 62. And then, so I want to do it on the fourth bounce. So I do 2/7 of 62. Oops. And I do 2/7 of that. So this one would give me the second bounce, third bounce. So I need to know the fourth. 2/7. I can just multiply 2 times 2 times 2 times 62 and then divide by 7, divide by 7, divide by 7. That equals 0.7. So it's not even bouncing an inch high anymore. Whoops, that seemed a little bit low, so I redid my calculations. I must have missed one of the 2's when I was multiplying. It's actually 1.4. Amber opens a savings account at a local bank. She earns money from an after-school job and deposits $47 each week into the savings account. After 5 weeks, the savings account has a balance of $781. Complete the function that models the relationship between the account balance, A in dollars, and the number of weeks, W, that have passed since opening the account. So this one shows that $47 times the number of weeks. We just need to find out how much money she had in her account to start with. So we know that her account is 781 when the number of weeks is 5. So 47 times 5 plus, what do we want to call it? The initial amount. Okay, so 47 times 5. So 47 times 5 is 235. So if I subtract 235 from each side, so let's write this over here, sorry. So that says 546 is equal to the initial amount. So that's what we were trying to find, was the initial amount. She had $546 to start with.